Intel has today announced the Core Ultra 200 series for desktop, aka Arrow Lake, which is set to introduce a brand new architecture to Intel's lineup and, in their words, set them up for the future of desktop processors. But the actual products being announced today, it's fair to say we have mixed feelings on what Intel has shown, and while there are some improvements here relative to 14th gen, it's questionable how competitive it will be. But let's take a look at what Intel have announced. The Core Ultra 200 series is an architectural overhaul relative to Raptor Lake that was used for the 13th and 14th gen Core series. The P cores have been upgraded to the new Lion Cove architecture, which Intel say is the fastest performance core for desktop PCs. The E cores have also been upgraded to the new Skymont architecture, bringing the overall desktop design up to the level of Intel's recently announced Lunar Lake lineup for laptops. Intel are claiming Lion Cove P cores provide a 9% IPC uplift versus Raptor Cove used in 14th gen, and there are some interesting changes here like the removal of hyperthreading, so 8 P cores now come with 8 threads, not 16 like in previous generations. There's also finer clock intervals, a wider overall core design, and L2 cache has been increased from 2 MB to 3 MB per core. The changes to the E-core are much more substantial, with Intel claiming a 32% IPC increase over Gracemont, their architecture used in Raptor Lake E-cores. This includes, again, a wider design overall, double the L2 cache bandwidth, and double the vector throughput. The same 4 MB of L2 cache is being utilized for each E-core cluster, a cluster remaining at 4 cores in size. The overall design continues to use 36 MB of L3 cache, which is accessible to both P and E cores and is contained within the compute tile. And yes, this is a multi-tile design instead of monolithic like with Raptor Lake, bringing the design from Intel's mobile line to desktop for the first time. However, the overall layout is different to their Lunar Lake laptop design with the use of more tiles. Arrow Lake has a compute tile, GPU tile, SoC tile, and I/O tile connected together using Intel's Foveros advanced 3D packaging. In contrast, Lunar Lake only has 2 main tiles, the compute tile and platform controller tile. It's also the first Intel desktop processor to be manufactured primarily at TSMC. Intel has made some mobile tiles at TSMC for the last few generations, but with Arrow Lake, all 4 main tiles are manufactured at TSMC. The compute tile is TSMC N3B, the GPU tile TSMC N5P, and both the SoC and I/O tiles are TSMC N6. This gives Intel a node advantage for the CPU cores compared to AMD's Zen 5, which sees each CCD built on TSMC N4. However, both companies are using TSMC N6 for the I/O part of the processor. The base tile and packaging process are manufactured and performed by Intel. The Arrow Lake launch lineup includes 5 processors: the Core Ultra 9 285K, which is the flagship, the Core Ultra 7 265K and 265KF, as well as the Core Ultra 5 245K and 245KF. Like with previous generations, K indicates an unlocked CPU and KF indicates an unlocked CPU without integrated graphics. The iGPU included with Arrow Lake is 4 Xe LPG cores. Now, the fully unlocked Arrow Lake configuration has 8 P cores, 16 E cores, and 4 GPU cores. So that's what you get with the Ultra 9 285K. In total, you get 24 threads due to the lack of hyperthreading. With the Ultra 7 265K, this drops to 8 P and 12 E cores, and then with the Ultra 5 245K, we get 6 P and 8 E cores. These are the exact same core configurations we got with 14th gen in the Case U, Core i9, i7, and i5 parts, so like with Zen 5, Intel are relying entirely on architectural improvements to deliver gains with Arrow Lake. One of the bigger changes with this lineup is frequency. Across the board, Arrow Lake is clocked lower than Raptor Lake for the P cores. The 285K drops to 5.7 GHz, down from 6 GHz on the 14900K. The 265K drops to 5.5 GHz, down from 5.6 GHz on the 14700K. And the 245K drops to 5.2 GHz, down from 5.3 GHz on the 14600K. For the flagship model, this amounts to a 5% peak clock speed regression, though it's just a 2% drop for the Ultra 5 model. Of course, we're just talking about peak frequencies here, not sustained or multi-core clocks. In any case, Intel are relying on that 9% IPC increase to deliver better performance than Raptor Lake, which factoring in this clock speed regression should be just a few percent faster on the P cores. On the other hand, E-core frequencies have improved. All models have a 4.6 GHz max E-core frequency, up from between 4 and 4.3 GHz on Raptor Lake. Base clocks are also up across both the P cores and E cores. As for memory support, Intel have beefed up this part of the CPU compared to Raptor Lake, with base memory speeds now hitting DDR5 6400. Intel are also claiming the sweet spot for memory is DDR5 8000, offering about 5% more performance than DDR5 6400. However, with the I/O tile on a separate piece of silicon compared to the monolithic Raptor Lake, it'll be interesting to see how memory latency fares in this new design, and this could be one area that doesn't move forward. Power is a big talking point with Intel CPUs, and this is the primary focus for Arrow Lake. Intel are claiming this new generation is much more efficient. But this is a two-sided story. Intel claim performance improvements, and they claim efficiency gains for Arrow Lake relative to Raptor Lake, but you won't necessarily get both of these at the same time in the default configuration. In fact, Arrow Lake CPUs are still rated at 125 watts of base power, aka the TDP, with maximum turbo power of 250 watts for the Ultra 9 and Ultra 7, or 159 watts for the Ultra 5. This is just a 3 watt reduction in turbo power for the top tier parts relative to Raptor Lake, and a 22 watt reduction for the Ultra 5 versus the 14600K. Intel tells us the default out-of-the-box motherboard configuration for Arrow Lake will remain as PL1 equals PL2 equals 250 watts for the top models, and PL1 equals PL2 equals 159 watts for the Ultra 5 K SKUs. This is the performance profile. In other words, despite claims of improved power consumption, the default maximum power draw of these parts will not be that different from Raptor Lake when run using Intel recommended and now default settings. Of course, some of the issue with 14th and 13th gen was the actual default settings being power unlimited. We're being told that won't be the case with Arrow Lake, and you'll see motherboards actually stick to the Intel recommended out-of-the-box settings. But just because the default experience is still a maximum of 250 watts doesn't mean there is zero efficiency gains. Intel are claiming half the power consumption for Arrow Lake versus 14th gen in lightly threaded applications that don't require all cores and thus don't need maximum power. This includes a 42% reduction in power for Cinebench 2024 single core and a 44% reduction in Procyon Office productivity. Gaming is another workload that doesn't typically utilize the full power requirements of the CPU. Intel are claiming a 73 watt power reduction on average, comparing the 285K and 14900K across a variety of games, with some reductions exceeding 100 watts. Then for multi-core productivity workloads like Cinebench 2024 multi-core, Intel are claiming they can achieve the same performance as the 14900K at half the power, but this is a configuration that users will have to manually enable in the BIOS. By default, both the 14900K and 285K will target 250 watts, with Arrow Lake providing a performance gain. But if you configure the 285K to 125 watts, it will perform about the same as the 14900K at 250 watts, and the gap in efficiency appears to grow between Arrow Lake and Raptor Lake when both are tested at lower power levels. This is where some of Intel's slides can be a bit deceptive at first glance. For example, in this slide, Intel are claiming up to a 19% increase in multi-thread performance for Arrow Lake, as well as up to 58% lower power in lightly threaded use cases, as well as the same performance at half the power. But you won't get all of that at the same time. You'll ultimately have to choose between the performance gains or efficiency improvements in heavy multi-thread workloads, and that efficiency configuration is something you'll have to manually access by reducing PL1 to 125 watts in the BIOS. In its default configuration, you'll only see lower power consumption in lighter workloads. So what are Intel claiming in terms of Arrow Lake performance in the best case? Well, we know IPC gains are claimed to be 9% on the P cores and 32% on the E cores, while the P cores have a lower frequency and E cores have a higher frequency. Overall, for heavy multi-thread workloads, Intel are claiming 15% better performance for the 285K versus 14900K, and this is with Arrow Lake set to PL1 equals PL2 equals 250 watts, and Raptor Lake set to PL1 equals PL2 equals 253 watts. In fact, this is the configuration Intel used for the vast majority of their testing. However, this is a geomean of just the 4 results you see on screen here. There's no additional testing folded into that number. As for single-threaded performance, Intel are claiming an 8% gain for the 285K versus 14900K, and this allows their part to outperform the AMD Ryzen 9 9950X by 4% in their single-thread testing. For multi-threaded performance, Intel are also claiming a 13% lead over the 9950X. In Intel's testing, they found the 9950X to be a little ahead of the 14900K generally, and that's also what we found in our benchmarking. So what Intel are claiming in these charts should be seen in independent testing. In fact, Intel are so confident this will be the case that they made a joke about this in their presentation, clearly in reference to the issues AMD had with benchmark claims that couldn't be replicated. These aren't earth-shattering margins, but for productivity tasks, Intel are claiming they will have the fastest desktop processor with the Ultra 9 285K. We didn't see any performance claims for the lower tier models, which is a little strange, as with the given hardware specs, I would expect the Core Ultra 5 245K with 6P and 8E cores to handily outperform the Ryzen 5 9600X in multi-thread workloads, which is already the case with the Core i5 14600K versus 9600X. The elephant in the room here is gaming performance. There's been some chatter on the internet about Arrow Lake being slower than the 14900K on average for gaming, and that's not exactly disputed by Intel, but it's not the full story either. Intel do claim the Core Ultra 9 285K and Core i9 14900K have the same gaming performance based on a geo mean of 31 games, and in the selection of 14 games shown here, performance is also roughly the same. Though in roughly half of the titles shown, Arrow Lake is slower, and some of these are with APO enabled. The qualifier to this is that while both CPUs are tested using equivalent PL1 equals PL2 power settings, Intel used base memory configurations for each part. So the 14900K is equipped with 32GB of DDR5 5600 CL28 memory, and the 285K is using 32GB of DDR5 6400 CL32 memory. We found with our 13th gen memory scaling testing that Raptor Lake gains a couple of additional percentage points using DDR5 7200 CL34 memory versus DDR5 5600. But then Intel also claimed the sweet spot for Arrow Lake is DDR5 8000 with an approximate 5% gain over DDR5 6400. Basically, performance could go either way when testing the optimal configuration for both parts, and with such tight margins between them, these sorts of things will matter as to which is overall faster. Intel claimed this level of performance gives the 285K parity with the Ryzen 9 9950X in gaming as well, again using a 31 game geo mean and shown through a 14 game sample. But in a 5 game sample, they showed the 285K losing on average to the Ryzen 9 7950X 3D while outperforming it in productivity tests. In these situations, they used DDR5 5600 CL28 memory for the 9950X, as DDR5 5600 is base memory for Zen 5, while DDR5 5200 CL28 was used for the 7950X 3D, again base memory for that platform. In our day 1 Ryzen 9 9950X review, we found that the 14900K was 7% faster than the 9950X across a 13 game sample using optimal memory. But in Intel's testing here, they are suggesting the 14900K and 9950X are more evenly matched. Based on these claims, this would make the flagship Arrow Lake processor better than the current fastest non-X3D Zen 5 CPU at gaming, though as always, you should take these numbers with a grain of salt given they are first-party benchmarks. The issue for Intel will be the X3D processors. Our testing found the 7950X3D and 14900K to be neck and neck, with Intel here claiming the 285K is slower than the 7950X3D in gaming. But the big kicker is that the 7800X3D is generally 5 to 10% faster than the 14900K across a large sample of games. With no real claimed performance improvement for the 285K versus 14900K, it's unlikely Arrow Lake CPUs will be able to offer the best gaming performance on the market, whether that's from the 7800X3D or upcoming 9800X3D. It'll be down to individual battles to see whether parts like, say, a 265K can outperform a 9700X, for example. In general though, Intel are claiming Arrow Lake's gaming performance has not kept up with gains seen in productivity, where performance is supposed to be 8 to 15% better. This is a very similar story to AMD with Zen 5, although this time I guess Intel are being upfront that Arrow Lake is not a step forward for gamers. There's a couple of other tidbits in here too. Intel are claiming Arrow Lake is easier to cool with an average of 13 degrees Celsius lower package temperatures while gaming compared to 14th gen on a 360mm AIO liquid cooler. This is likely due to reduced power consumption while gaming, so I'll have to see how temperatures fare in all core workloads. Intel also claimed the Core Ultra 7 265K is about 5% slower than the 14900K for gaming, which is probably going to make it around the mark of the 14700K. In our testing, the 14700K is about 4% slower than the 14900K. Then there's the platform. Arrow Lake will be on a new platform, LGA1851, using 800 series chipsets. This platform is a modest upgrade over LGA1700, dropping support for DDR4 and increasing PCIe capabilities. The CPU now supports 20 lanes of direct PCIe 5.0 connectivity, up from 16, in addition to 4 lanes of PCIe 4.0. This means Arrow Lake now supports both the primary x16 slot and primary M.2 slot over PCIe 5.0, whereas the previous generation capped to PCIe 4.0 for the primary M.2. There's also dual Thunderbolt 4 connectivity directly on the CPU. The 800 series chipset, in particular Z890, will support up to 24 additional PCIe 4.0 lanes, replacing the split of 20 PCIe 4.0 and 8 PCIe 3.0 on Z790. USB, SATA, and Wi-Fi support is the same as previous. Relative to AM5 on X870E, Arrow Lake with Z890 will therefore have slightly less PCIe capacity directly out of the CPU, but the chipset supports double the amount of PCIe 4.0 connectivity and more USB connectivity as well. The big disappointment out of this presentation is that Intel are making no claims or promises of future CPU architecture support on LGA1851 and refuse to answer our questions about it, saying they didn't have details to share on future products. With no promises or claims to buyers that LGA1851 will have any sort of platform longevity, it's safe to assume this is a typical Intel platform with at most 2 generations of CPU support. That's certainly been the case when they have refused to comment on future CPU support with other platforms. In fact, some recent rumors have suggested there might only be 1 CPU generation on this platform, which would be incredibly disappointing, though this is totally unconfirmed at this stage. The only thing we can take away from this is there is no long-term support for this platform. In the best case, LGA1851 will offer similar future CPU support to AM5, where AMD is expected to offer at least 1 additional CPU generation on AM5. Worst case scenario, AM5 with promised support to 2027 plus actually ends up with greater platform longevity than LGA1851. As usual, Intel buyers will be going into a new CPU generation with no expectation their motherboard will be useful for CPU upgrades, and there's no key platform selling point compared to AM5, despite a new platform and new architecture, aside from, I guess, more PCIe. Lastly, we get to pricing. Arrow Lake will be available on October 24 at roughly the same prices as Intel's 14th generation processors. So the 285K at $589 US, the 265K at $394, the 265KF at $379, the 245K at $309, and the 245KF at $294. Some models are $5 to $15 cheaper than Raptor Lake Refresh, but nothing substantial to shake up Intel's usual pricing scheme. Relative to AM5 processors, this pricing structure is nothing exciting. The 285K will be going up against the 9950X at $650 and the 7950X at current $515 US pricing. Intel are claiming their new Arrow Lake flagship should be faster than both of these parts for productivity, but value doesn't seem much different to the 7950X, which has been available for between $500 and $550 all year. The nearest competitors to the 265K are the Ryzen 7 9700X at $360, as well as the Ryzen 9 7900X currently at $425. If application performance ends up outperforming the 14700K, this part would be good value up against the 7900X, which is slower than the 14700K. The 245K will be up against the Ryzen 5 9600X at $280, as well as the 7700X at $250. Depending on where the 245K sits relative to the 14600K, there's a chance this part will be okay for application performance. Where Intel might struggle with this lineup is gaming. Based on Intel's claims, Arrow Lake's gaming performance should fall somewhere between base Zen 4 models and the 7800X3D, with the 7800X3D outperforming it. The problem is you can buy a Ryzen 5 7600 for a little under $200 US, whereas the cheapest Arrow Lake part announced so far is $294. Based on Intel's presented information so far, this doesn't look like a particularly impressive deal for gamers, and for those after the best gaming performance, the 7800X3D and its upcoming successor will likely deliver better performance at a lower price than Intel's Arrow Lake flagship. Whether or not these parts are worth buying for gaming will come down to the margins and where parts like the 245K end up. Overall, Intel's Arrow Lake announcement is pretty much as expected. As Steve and I have discussed in our podcast throughout the year, Intel returning to a leadership position in desktop CPUs is going to be a multiple generation journey. Making a new generation both much faster and much more efficient in one hit was always going to be a challenge, and with Arrow Lake it seems Intel have targeted power consumption over performance. In Intel's presentation, they even talked about this generation as a bit of a reset that will set them up for the future. With all of that in mind, it's still hard not to be disappointed in what Intel showed off. While Intel are claiming application performance has improved by a little bit compared to Raptor Lake, and Intel believe this will make the Core Ultra 9 285K the fastest productivity CPU, stagnated gaming performance is not ideal. I guess Arrow Lake is positioned to be a more efficient gaming CPU, but whether this makes it worth buying over AMD's Zen 4 and Zen 5 lines is questionable, and we're just not sure whether it will end up being better than Zen 5 for gaming power use, which is really the main advantage to Arrow Lake compared to 14th gen. There's two things Intel could have done to make Arrow Lake more attractive to buyers when faced with CPU hardware that isn't faster in every key area, and they did neither of those things. One is to provide a strong commitment to future CPU generations on the LGA1851 platform. Something along the lines of buy Arrow Lake now and you can upgrade to more powerful parts in the future. Intel, didn't do this and refused to comment on platform longevity. The other is to make Arrow Lake very affordable and try to win customers based on value, but Arrow Lake uses the same pricing structure as 14th gen, so they're not attempting to do that either. Unless there are big positive surprises in terms of final performance, and we'll have our reviews for you around launch on October 24, Intel haven't shown a processor today that is going to make much impact on the CPU market in our opinion. I don't think they've put forward a strong case that Arrow Lake has substantial advantages against Zen 5, but they have shown claims of improvements relative to 14th gen Raptor Lake. Whether or not that will be enough to get a recommendation, well, you'll have to check our review to find out. Anyway, that's it from us in terms of breaking down this Arrow Lake announcement from Intel. These CPUs should be available in just a couple of weeks, so there's not going to be too much time until you'll be able to see final performance. And with these latest couple of CPU generations, I think where these parts are going to end up in terms of performance is going to be just a couple of percent either way in terms of things like gaming performance. Intel are claiming the same performance between Arrow Lake and Raptor Lake. Does that mean 2%? Does that mean 1%? We've been talking a lot about that with Zen 5, so we'll see how that goes for Arrow Lake as well. But yeah, lots of single-digit margins and single-digit battles should be happening across this CPU generation. So we'll see how that goes once we get our hands on these CPUs in the coming weeks. Anyway, that's it for this one. Thanks for watching. If you want to support the channel, we have our Patreon page. Links to that are in the description below. You'll gain access to some cool things like our monthly live streams, our BTS content, our Discord chat. So yeah, plenty of good stuff in there. Thanks for watching. I'll catch you in the next one.